Hello class, welcome to our lesson on 10.3, Arcs and Chords. So please turn to your third page in your circle book and draw very similar to what I have up here. You're going to draw two different diameters, one right here and one right here, and then draw two different chords from A to B and from E to D. So please draw that on your circle book as well. Our first property, in a circle, if a diameter or a radius are perpendicular to a chord, then it bisects the chord as well as the arc. So perpendicular means 90 degrees, of course. So if this radius is perpendicular to chord AB, then it bisects the chord. Let's say the chord is 10 inches long, then FB would be 5 inches then, and so would AF, 5 inches. It also bisects the arc. So if arc AB right here is, let's say, 40 degrees, then arc AF is 20 degrees, and arc FB is also 20 degrees. Okay, so that's one of our properties here for our circle book in 10.3. Another property is that in a circle, two chords are congruent if and only if they are equal distance from the center. So if F and C is 11, and C to G is also 11, then the two chords, AB and ED, are congruent to each other. Okay? Or we could have said it the other way around because it says if and only if, so that means that the converse is also true. So if we said that this chord is equal to this chord, then they are both the same distance away from the center of the circle. Okay? So that's our second circle book property. The third one, in a circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we know that AB, that chord, is the same length as segment ED, that chord, then we could say arc AB is congruent to arc ED. Okay? There's our third circle book property. The fourth one is kind of more terminology, and I'm not going to give you the formal definition, but the two terms here are inscribed and circumscribed. Circumscribed, like if you think about the word circumference, that's the length around a circle or the distance around a circle. So circumscribed is around a figure. In this case, it's around a polygon or a quad. And inscribed, I want you to think of the word inside. When you think of circumscribed, like this quadrilateral is inscribed, it's inside the circle. And what's very specific about inscribed is that all of the vertices are on the circle. And that's what inscribed means, is when all of the vertices lie on the circle. So I could have a circle, and then I could have a triangle. We would say that this triangle is not inscribed. Even though it's inside, we wouldn't say it's inscribed. If I did this, now the triangle is inscribed. Okay? All of the vertices lie on the circle. And so when you think of circumscribed, you should think of the outside. So this circle is circumscribed about the quadrilateral. Okay? So that's those two terms. All right, that's everything in the circle book. So this completes the circle book right now. Now in our notes packet, we have two problems here in our notes packet. So let's do these two together. EF and GH are equidistant from the center, where PQ and PR represent the distance from the center to each chord. The radius of circle P is 15 centimeters and EF is 24 centimeters. Find PR. Well, I want to find PR. I want to find that length, that segment. So I'm just going to put an X right there because this is going to be my answer. That's what we want to find. All right, let's start off with this piece of information. EF and GH are equidistant from the center. So if they are equal distance from the center, that means that this and this are congruent to each other. And along with that, if they are congruent to each other, then this chord is congruent to this chord. One of our circle book properties is that if that two chords are congruent if they are equidistant from the center. So if they're equidistant from the center, then chord EF and chord GH are congruent. So that's important. Now, the next piece of information, it says PQ and PR, which are congruent, we know now, represent the distance from the center. Remember from chapter 3, if it represents the distance between a point and a line is always the perpendicular distance. So now we conclude that this angle right here is 90 degrees, and this angle right here is 90 degrees. Okay, because the perpendicular distance makes that 90-degree angle. And now we know that if this segment, PQ, is perpendicular to the chord, then we also know that it bisects the chord. So now we have QF is congruent to EQ because it bisects that chord. And because PR bisects chord GH, then GR is congruent to RH. What a day. So we know all that stuff. It says the radius of the circle P is 15 and EF is 24. So if EF is 24, we could say that this piece is 12 from E to Q, and segment QF is also 12 because 12 plus 12 is 24. In the same way, segment GR is 12 and segment RH is 12. All right, so now we just got to put on this radius is 15. Now, I don't see any radius in the circle right now. And so what we're going to do, class, is we're going to draw a radius. Now, circle P, so any segment from that point, circle from point C, the center of the circle, to the outside of the circle is a radius. It wouldn't make any sense to draw this radius, even though that segment is 15 centimeters. It wouldn't make sense to make that segment, even though it's a radius, it is 15 centimeters. Instead, let's draw it in a place that helps us. And I would say what helps us is from P to G. That is also a radius, isn't it? And now, how does that help us? Bangarang! This is a right triangle, right? In a right triangle, the Pythagorean theorem exists, and if the radius is 15, now I can say x squared plus 12 squared, the two legs, that equals the hypotenuse squared, which is this 15. Okay, so we strategically put the radius in there in such a way that it helps us solve for our missing segment PR, which is our variable x. Here we go. X squared plus 144 equals 225. I subtract 144 from both sides. X squared equals 81. Square root both sides. X equals 9. So our segment PR is 9 units long. Fun stuff, isn't it, everybody? Good stuff. All right, last one for the day. The radius of our circle is 52, circle C, and the length of MN is 32. Find the length of LO. All right, so if MN right here is 32. Now, isn't CM a radius, right? CM is a radius, and the radius is 52. So if MN is 32, wouldn't we say that CN is 20? Because 20 plus 32 makes 52, and our radius, of course, is 52. All right. Now, because we see that this is 90 degrees, so it bisects the chord then, I could now solve for ln. This is x. This is what I'm going to be finding right away. And the radius of the circle, I'm going to draw another radius, just like I did in the last one. I'm going to draw it in a strategic place that helps me solve for my missing segment ln. Whew! And that radius is 52. So 52 goes right there. Now I have another right triangle, right, everybody? I can solve using Pythagorean's theorem. So 52 is my hypotenuse. 52 goes on the right side by itself. My other two segments are x squared plus 20 squared. And let's solve for x. X squared plus 400 is 20 times 20 equals 52 times 52, which is 2704. Subtract 400 from both sides, so x squared equals 2,304. Square root both sides. If you square root 2,304, you get x to equal 48. And notice how 48 is one of our options, and people kind of do this all the time, and that is not the correct answer. Because that's the length of ln. ln is 48. We want the length of LO, right? So if x is 48, if CM is perpendicular to LO, it bisects that segment, so that means this one is also 48. So what is 48 plus 48? Segment LO is 96. So make sure you're aware of that as you're doing your homework. Let me know if you have any questions on that lesson when you get to class. See you later.